you guys for joining. This is the Oracle Machine Learning Office Hours. Today we have a very special session. This is going to be Oracle Machine Learning feature highlight, how to deploy a Python XGBoost model using Oracle Machine Learning Services. So Sherry LaMonica is going to be presenting, and myself and Mark, we're going to be monitoring the Q&A. So anytime you guys have questions, please feel free to ask. And I hope you guys have fun with the session. And thank you very much, Sherry, for joining and sharing that. And I'll pass it on to you.
Thank you, Marcos. And hello, everyone, and welcome to this Ask Tom session. As Marcos said, I'm Sherry LaMonica, a principal member of technical staff in the Oracle Machine Learning Product Management team. And today I'm going to show you how to train a Python XGBoost model, convert the model to ONNX or the Open Neural Network Exchange, and then deploy the model to OML Services on Autonomous Database. So to set expectations, this is not a full OML Services presentation or an XGBoost tutorial. Marcos did a dedicated OML Services session, and that's saved in the Machine Learning Ask Tom recordings. I have multiple things lined up, and I'm going to start with the motivation for using ONNX with OML Services, and then provide overviews of OML Services and ONNX, and then show a demo to help you understand the technical concepts related to ONNX and OML Services. And finally, we'll open the floor for Q&A. Okay, so let's get started with the motivation for deploying an ONNX model using OML Services. So OML Services simplifies the task of putting Oracle machine learning models and third-party models creating using tools like XGBoost and Scikit-learn exported as ONNX models into production. When you use OML Services, which is a REST API, to deploy an ONNX model, you're essentially combining the advantages of different frameworks to streamline the entire model deployment process. So you can use ONNX models with OML Services if the algorithm is not available in Oracle database, as in our case where XGBoost is not available in the target database version 19C. For very fast and cost-effective scoring, because the scoring is done in an efficient middle tier. And also, if you have a requirement to separate development and deployment environments, for example, with web applications. So now let's do a quick overview of OML Services and ONNX to understand how they work together. So Oracle Machine Learning is a family of different products, and they work together in the database. And in Autonomous Database, we have OML for SQL, OML for Py, OML Notebooks, and soon we'll have OML for R. And then we have the Data Miner UI and OML for Spark, which runs in Big Data Service. And then we have the AutoML UI and OML Services. And OML Services extends some of the key attributes we have for machine learning. And the main feature is deploying models very quickly in production. It helps with model deployment and model lifecycle management, and we do that for in-database models and for ONNX models, which is what we'll show today. So here we have a look at the architecture and REST endpoints provided by OML Services. If you look at the upper connection, we first do that from our REST client by sending the Oracle Machine Learning user and password to this OML user's REST endpoint to get a token, and that's Autonomous Database. And when we get a token back, we can do all of the things that are below, all the actions, the get, the post, the delete through a REST API. And these are the endpoints that are in the data center where your Autonomous Database resides. And they provide several capabilities, and we're going to see them, but basically storing your models and running scoring endpoints. And for ONNX models specifically, we have endpoints for storing, deleting, and listing deployed models and retrieving model metadata, model details. You can also organize models within namespaces, and you can create, delete, and list your model endpoints and score data using model endpoints. And it's worth noting that with OML Services, we do the scoring in single records or mini batches of records. So that's the overview of OML Services and its capabilities. So next we'll talk about ONNX. ONNX is the Open Neural Network Exchange, and you can think of that as an intermediary or a coordinator between different development frameworks and target environments. It promotes interoperability, portability, it promotes efficiency and optimization by creating flexibility in the model lifecycle. It's a common file format for machine learning models across different frameworks. And so not just neural networks for deep learning models, as the name indicates, but also for classical machine learning models as well. And the idea is that you can train a model with one tool stack and then deploy it to another for scoring. So with ONNX, you're essentially exporting a reusable component that can be transferred between frameworks, provided they support ONNX. And once the models are in ONNX format, they can run on a variety of ONNX compliant tools and frameworks for scoring. So for the example that I'll be showing you today, I trained the XGBoost model and exported it to ONNX in a Python engine outside of Autonomous Database using a Jupyter notebook. And you can use your own client notebook for the model training and export as well. And after exporting the model, I deployed it using OML Services on Autonomous Database. And these are our Python dependencies. So in order to use ONNX in our development environments, we need two Python packages, ONNX and ONNX ML tools. And this is easy through a simple pip installation. And once you have these libraries installed, you're ready to use ONNX. And having the two dependencies basically boils down to the decoupling of conversion tools and ONNX itself. And this diagram explains things. We train the XGBoost model in Python using the XGBoost package. And when we convert the model to ONNX, this is the responsibility of ONNX ML tools. And then finally, the model is exported to ONNX and it can be deployed to OML Services or another ONNX runtime. Okay, so now I will show you the example. Okay, so here's my Jupyter notebook. And as I mentioned, we're going to train a sample XGBoost model, just a toy model, convert the model to ONNX format, and then deploy the model to OML Services on Autonomous Database. So what we're doing here is we're creating a model that can predict the average house price based on its characteristics using the Boston house price data set. So the first thing that we do is import the data from the Scikit-learn data sets. And here I'm just looking at a description of the data. And then next, we separate the data into target and predictor variables and then split the data into test and train sets. Now we initialize the regression object using the XGBoost package has an XGB regressor class. And when we initialize the regression object, we're passing the hyperparameter values as arguments. Then we train the model using the fit method and make predictions using predict. The next step is to convert the model to ONNX. So OML Services needs the model in ONNX format, zipped together with a metadata file, a metadata.json file that tells us the mining function of the model. And in our case, so it would either be regression or classification. And in our case, that will be regression. So I import the libraries that I need. And basically right here, I'm just setting up the directories on the system where I'll be exporting the model, the ONNX model. Before I can export the model to ONNX, I have to run a model with dummy input. And the values of the input, which are called tensors, they don't matter, but we do need to make sure that they're the correct shape and type because Scikit-learn does not store information about the training data. So we need to basically tell the ONNX runtime what to expect. And for this reason, we have the convert XGBoost contains this argument called initial types to help us define the model inputs. And here I've given the name for the input float input, and the shape is specified right here. And the first dimension is the number of rows, and the second is the number of features. And the number of rows is going to be defined as none because we don't know the number of predictions that when the model is converted. And this step right here actually converts the model to ONNX. We use convert XGBoost, and that's from ONNX ML Tools. And we're saving the model to a name of our choice, which is XGBoost ONNX. And when we do this ONNX conversion with the convert ONNX function, all the model details are serialized into this ONNX file with the provided name. Then, as we mentioned, we have to populate the metadata.json file with the mining function, which is regression. And then we're zipping everything up so that we can deploy it with OML services. And if you're interested at taking a quick peek under the covers for this ONNX model, you can print the string representation of the model like I did here, or you can use, there's a Python package called Netron, which will allow you to view this graphically. But it contains the version of ONNX ML tools used to create the model and a text representation of the model structure. Okay, so ONNX has its own runtime. Here we're scoring the data using the ONNX runtime just to validate that the model is working properly. And what we do here, we have to create this inference session that loads the serialized model and then maps the metadata to the runtime model, which is this section right here. And then we can run the predictions. And here I'm printing out the first 10. Then I verify that the ONNX and Scikit-learn predictions are similar, and they are. So now that I've validated the model, I can deploy it in OML Services. And this is the final step. Again, OML Services is a REST API, and it's on Autonomous Database. You do have to start by getting a token. So here I'm using curl. You can use any REST client that you want. A lot of our examples use Postman, but I'm using curl for the sake of the notebook. And so this would be in a Linux terminal, and I would export these different variables, my OML server, the tenancy OSID, my database name, username and password, and I would export those to variables so that I could pass them to my curl commands to start to get a token. And I'm passing this to the token endpoint, which is that OML users token endpoint. And once I send my username and password over to the token endpoint, it returns a token to me, and I can export that token to a variable and use that token variable for my downstream REST calls. The token is good for, this is in seconds, 3,600 seconds or 1 hour, and it can be refreshed. Okay, so now that I have a token, I want to save my model to the OML Services repository. And I'm doing that with a post request to the models endpoint here. And you can see for the model data, I'm passing the serialized ONNX file in the zip, and then the model name, the model type, and then optionally a description of the model, a namespace, a version, and whether or not the model should be shared. And I'm parsing everything with JQ, which is a Linux command line JSON parser, because the JSON data that's returned is not really human readable, and JQ will bring it back in a nice format. And you can install JQ on your Linux machine with a simple yum install. And so this brings back a model ID. And I can then deploy the model and create a scoring endpoint by providing the model ID to the deployment endpoint. And so now I have the reference to the model and the model ID, the URI, and a timestamp on when this was deployed. So the model is now saved in the model repository, and you can view it in the OML notebooks area in Autonomous Database, which I won't show today, but you would go to models and look under deployments And you could basically get the same information that from the REST API by looking under deployments. And this is through basically by passing the model URI to the deployment endpoint like this. And you can see, again, we've got the model ID, the URI, the reference to the model, and the deployment timestamp. So now we'll make predictions on the model that we just deployed using the scoring endpoint. You can see I'm passing the model URI to the scoring endpoint, and I'm inputting a single row of records, and I get a single score back. And that's it. That's how you deploy an ONNX model using OML services. You could also do this with mini batches of records, which we don't show here. I'll probably add that to this notebook before we post it in the Ask Tom, so you can see how that's done as well. And then finally, if you want to delete a model, you would first delete the model endpoint and then delete the stored model using the model ID. So let's go to our Q&A.
Thank you very much, Sherry. Okay. Yeah, so I was just typing back an answer here, but we've had a good set of questions. One is, does it only work in autonomous database, and or can we follow the same process on on-premise database as well? So I was answering that Oracle Machine Learning Services is only available in autonomous database today, and on premises you could use this same method to create your own ONNX model, but then you wouldn't be using any of the Oracle Machine Learning products to score, right? On premise, then you would have to use your own ONNX runtime, right, potentially. And then you could use, at that point, JDBC or any other method to pull data from your on-premise database into that scoring engine, right, at that point. So there's another one, which is, what is the setup in regards to logging? So where can I find a log of all the scoring done? So that's part of the Oracle Machine Learning Services side. So we are studying ways to get customers access to the logs. We currently today we don't store that for too long, right? Because these are, if you think about it, every of these kind of scores, right? They take really milliseconds. So we have a login in the back to make sure that we are measuring even CPU use, right? So that if you run like a 24/7, thousands of scores a minute kind of process, then we're going to charge you for CPUs on the autonomous database service. But more often than not, you wouldn't even see a bill, just because if you're scoring, eventually these scores are just so fast, right? So it might be something that we can enhance for the future, let people see every score they're doing there. But right now it's not in the service, so it's in the plans. Another question: is there a way to upload the ONNX model file using a web interface on the OML services in autonomous database? That's a good question. So right now we only have the REST APIs, so we don't have really a UI where you can do that, right? You either have to call curl or use Postman, but basically we have a REST interface. So that might be a good idea for the future, to potentially help us with model management, right? And then managing the files themselves. So that's a good idea for the future. Other question: architecturally, do you recommend the scoring machine be set up as an independent instance? So I assume you're asking maybe for on-premises. So if you think about the service, OML Services, it's already an independent, let's say, engine, right, running next to the autonomous database. So it's in the same pod, in the same data center, but it is running its own engines, and it's caching the models in memory. It's got its own database engine there for scoring OML models and things along those lines. So if you're doing that physically on premise, for example, it probably is a good idea for you to have an independent instance if you're doing ONNX models, right? Because you need an ONNX runtime running somewhere. If you're scoring OML models, right, then at that point they are scored inside the database, so you don't really need any separate thing. So go ahead, Mark.
Yeah, I was just going to say another alternative to interpreting that question is, do we recommend having a separate autonomous database instance to support the OML services? And I think that takes a different tack, that the OML services is supported by the region or data center. And so it's not, while your account is tied to a specific autonomous database instance, it's not necessarily tied to the compute resources of that instance directly. So that's something to keep in mind, that you don't have to say, do I need a separate autonomous database instance in order to use the OML services effectively? You don't.
That's great. So another question is, I did not follow how the input parameters required for the scoring are defined. As in, what parameters and data types are expected by the scoring endpoints is defined.
Right. So connect with me offline, and we can go more in depth into that.
Yeah. So I think basically but looking at what you were doing, Sherry, I think the basics is, once you build the model, then the ONNX does not know what format the input is. So you just need to take a sample data of those same types, and then just pass that as together with the to process right into that ONNX pool.
So that the ONNX runtime that it's consumed by understands the shape that it expects.
Right. Okay. Another one, is there a way to graph the resulting decision trees for GBMs and such? I guess that from the XGBoost output. So potentially there might be a package, right, that can map those things in XGBoost. But that would be like an open source package, right, of sorts in the Python side. I think
right, we don't have that in OML services.
Right. Another one is, I am new to ONNX. Is vice versa also possible? Like model build on ADB can be converted to ONNX models? Will export serialized model API serve the same purpose? So it's not exactly the same. I mean, right now we can't convert the in-database algorithms into ONNX formats. The in-database algorithms, at least for now, have always required on a database somewhere. So yes, you can use export serialized model API in with your autonomous database, for example, and export a model, and then import that model in a different, either a different ADB, right, or an on-premise autonomous database. So as long as you have the same releases of things, it will be very easy to deploy a model that you built or developed in one place into another autonomous database or an Oracle database on-premise. But you need to have a database there. So today, you can't really export an in-database model into ONNX format, let's say, right? That doesn't stop us from thinking about that in the future. But for now, we have found ONNX has its own limitations, right? And it doesn't have all the transformations and things that we do in OML for now. Go ahead, Mark.
But just to add to that, you can export the in-database models into OML services, of course. It's using the in-database representation, not an ONNX representation. And as we've shown in past office hours, and Marcos has demonstrated, with the AutoML UI, you can go directly from an in-database model to import it into OML services.
Exactly. And then another one is, which machine learning algorithms are supported and not supported by ONNX? Are there any restrictions of number of algorithms supported by ONNX?
No, that's a good question. They basically say classification or regression. I think as long as the model can be consumed by the ONNX runtime that is being supported, it should work.
Right. And as long as, so it's got to produce output like predictions.
Right.
So today it's classification and regression. We're thinking about expanding that capability, but for now is regression, basic regression, and then classification. You can get a multi-class as well, but we also support image classification, right? So if your model, your ONNX model is actually doing a classification of an image, then we can take as an input, for example, a JPEG, right, or a PNG file, and then we can process that and then get back to you with the categories that your ONNX image classification was doing, right? So there are examples of that. If you guys want to go into the previous Oracle Machine Learning Services session that we did, we have a full session on that, and we have an entire hour and a half hands-on lab as well that we did. So both would show you all of these options and capabilities.
Any other questions?
There was one in the chat is there something showing model drift and model explainability? You know, what features were most important in its inference? And well, model drift is something that is on the roadmap for models in general. You can look forward to seeing that in the future. But as far as model explainability, you can get the set of factors that were most influential in that prediction. And so that is something that's available with the in-database models.
Okay.
Right. And then let's see. So another one is, does this totally replace predictive SQL in terms of strategic direction? I would say no, right? I mean, what we're doing here with autonomous, right, is basically using OML services for that additional capability. But for any SQL users, right, the capabilities are still the same. Now, bear in mind that OML services also are, as Sherry mentioned, right, OML services can support mini batch scoring, right? So normally we expect people to use OML services with scoring like, you know, maybe 200, 250 records most at a time. We don't expect you to pass, you know, I have 1 million records I need to score now, right? If you have 1 million records to score, I think we mentioned that before, we expect you to use SQL, right? And normally, you know, put the model in a database and use SQL to push that model to score that. Now, having said that, we do have plans for an upcoming version on OML services, which is going to allow you to do batch scoring. And we expect that to extend to ONNX as well. So look for that in the coming months. And then last one is, are clustering association rules time series algorithms supported by ONNX? I mean, not today, not from our side, right, Sherry?
Right, exactly. And I didn't see any time series examples in the ONNX model zoo, but yeah, that's something that I'd have to look into.
Yeah, and I think there are some limitations on ONNX itself of the kinds of things that that they can do, right?
Mm-hmm.
Another question is, what are pre-trained models deployed for cognitive text and image classification in OML services? How can I get more details to learn about these pre-trained endpoints? So, Abhijit, the pre-trained cognitive text, yes, those are pre-trained models that we do with using Wikipedia. If you can watch, I think we did one of the OML services sessions where I explained in detail the information about how we do with Wikipedia data, right? So today, and we launched the Italian language last week, right? So we have, for that we have English, Spanish, French, and Italian, right, so far. For the image side, we don't really have pre-trained models. So for the image classification, we expect you to provide the model, right? So just like Sherry did today with the XGBoost, you would go do a TensorFlow model or run any of the image classification models, and then as long as you have that in an ONNX format where the output are the probabilities for classes, then we can take that in and then you can use in OML services. So great. That was a lot of great questions. Thank you guys a lot for all the great questions and feedback. Thank you, Sherry, for all the great work here. So we're going to share Sherry's notebook with the session. So next time you guys see that, you guys are going to get an email with the recording. When you go into that link, you're going to see the YouTube video there, but you're going to see links below that. One of them is going to be the slides. The other one is going to have the notebook that Sherry just did. Okay,
thanks
guys.
Everyone for joining.
Cool. Thank you very much. Thank you, Sherry. Thanks a lot, and talk to you guys next week.